Today we're covering section 7.3, looking at geometric sequences and series. So we started off the chapter looking at sequences and series in general. We looked at arithmetic ones in section 7.2, where we are adding and subtracting the same thing each time to get to the next term. And now we have geometric sequences and series, which will have a common ratio between the terms. So we're going to be multiplying or dividing by the same thing every time. So we can see if we multiply by 1/3 here, that will get us to each term. So yes, that's geometric. In this one, we multiply by 2, then we multiply by 3, then 4. So even though there's a pattern, we're not multiplying or dividing by the same thing each time. In this one, just note that if you multiply by a negative each time, it will switch. So this is geometric because we're multiplying by a -2. So it's switching back and forth between positives and negatives, but that's okay. If we want to write a rule, we have this nice formula where it's just the first term times the common ratio raised to the n minus 1 power. So in this example, our first term is 4, and our common ratio is 5. So our rule is 4 times 5 to the n minus 1. Be careful, you can't multiply the 4 and the 5 together to get 20, because we'd have to do the exponent first. So this is your final answer. This lets us find any term that we want. So if we wanted to find the 7th term, we'd plug in 7. If we wanted to find the 100th term, you'd plug in 100 in that spot. And then the last thing is that when we're trying to find the series, that's just taking all the terms in the sequence and adding them together. You can do that longhand. Like in this example, I could plug in 1, plug in 2, plug in 3, plug in 4, all the way up to 16, add them all together. Or we do have a formula. It looks a little scary, but it's not too bad. Formula takes the first term, so what you get when you plug in the first number, times 1 minus the common ratio raised to how many terms you have, over 1 minus the common ratio. N will be the number of terms you have, so in this case, most cases it's going to be this top number, as long as the bottom is 1. If the bottom's not 1, we'll actually have to count and see how many terms we have between the bottom and the top. So let's look at a few examples. In the first section, they're just going to be finding a missing term. So you just want to look to see how you're moving from one term to the next. Remember, it's always going to be multiplying or dividing. So in this case, we're multiplying by 3. So multiply the 6 by 3, get 18. Multiply that by 3 to get 54. I always just like to check that that continues on. So in this case, we would get 18. In the second one, just be careful. We're going from positive to negative. So we need to multiply by a negative number. So that would be -3. So that would turn it into 27. And then multiplying that by -3 gets me to the next one. Multiply by -3 gets me to the next one. If you have fractions, sometimes it's just easier to look at the pattern in the top, pattern in the bottom. Sometimes you want to look at the fraction overall. But in this case, we're multiplying by 1 in the top, multiplying by 3 in the bottom. So multiply by 1 in the top to get 1. Multiplying by 3 in the bottom would give me 6, 18, 486. Check that. Right. Hopefully that first section goes pretty fast for you. Same thing with the second part. We just have to remember what we're plugging into the 2 spots into our formula. The first spot will always be the first term. So in this case, it would be 4. And then in the parentheses, that's our base. That's going to be our common ratio. So in this case, I'd be multiplying by -4 to get from each term to the next. So -4 goes in the parentheses. They won't let you simplify that. That's going to be your answer. But just in general, if you're writing this, make sure you don't multiply those two together. And then we'd have to the n minus 1 power. Once again, you're just going to have to fill in those 2 spots. So the first spot is the first term, and then the second spot is your common ratio. Once again, I hope that section goes pretty fast for you. Last section is where we want to use our formula to find the sum. You could go about doing this the long way. Plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, plug in 6, plug in 7, plug in 8, plug in 9. Keep track of all those things, add them all together. I think the formula is going to be a little bit easier. Remember, the formula is the first term, so what we get when we plug in 1 times one minus the common ratio raised to the number of terms that we have over 1 minus the common ratio. In our case, the first terms, when we plug in 1, 1 minus 1 in the exponent gives me 0, 2 to the 0 is 1, so 3 will be our first term. Multiply that by 1 minus our common ratio. Common ratio from the formula is the base of our exponent, so it's going to be 2, raised to the number of terms we have. In this case, we have 9. Be careful if it doesn't start with 1 at the bottom. You need to count and see how many things are in between your bottom and the top. And then 1 minus 2 in the bottom. Cleaning that up, we have 3 times negative 1 on the bottom of this fraction. And then I need to figure out what 2 to the 9th power is. So we get 512. Take 1 minus that, it's going to be negative 511 on top. Divide that by negative 1, which gives me 3 times 511. Give me 1533 for our final answer. Hope that helps as you're working through your IXL problems. As always, if you have questions, please email, Flipgrid, reach out in some way to get help.